Welcome back. As I told, as I'm speaking, I'm going to set the stopwatch. Hope you don't mind. As I told you in the last lesson, I have not dealt much with inverse-trig functions. I did give the definitions and all, and then I also deduced the derivatives and did a couple of questions. So I want to do a couple of more questions and also do integration. So what I'll do is I'll put both differentiation and integration formulae here, and then do some questions to go over how to differentiate and how to integrate inverse-trig functions. So d by dx of arc sin x is 1 over root 1 minus x squared. Therefore, integral 1 over root a squared minus x squared dx is sine inverse x over a plus c. When you differentiate this, you'll get that answer. That's what it means. But we don't use the one for cos inverse. Cos inverse is only for differentiation. So if I come across a question, I'll just quote the formula and use it. You don't have to prove any of these formulae unless you're asked to. You can just quote and use them. Similarly, d by dx of arc tan x equals 1 over 1 plus x squared. So integral 1 over a squared plus x squared dx is 1 over a arc tan x over a. These are the only two standard formulae, but if it is sec inverse or something, we will use substitutions. Okay? So let's do some questions on differentiating and integrating these things. Find dy by dx. This is just a revision sort of questions. So we go over the formula. Y equal to 2 arc sine x minus 1 over 3. Yeah. So back to square one. To differentiate this, I'm using function of a function or onion rule or chain rule. So dy by dx equal to 2 is a constant. Arc sine gives you 1 over square root 1 minus x squared times. That takes care of the arc sine. I have to differentiate x minus 1 over 3. When I differentiate x minus 1 over 3, I get 1 over 3. So it is 2 over 3. You're expected to simplify this. It's 9 minus x minus 1 the squared over 9. That is 2 over 3, 1 over, so root of 9 minus x squared plus 2x minus 1 whole over root 9, which is 3. So they cancel. So it is 2 over 8 plus 2x minus x squared under root. That's how you differentiate arc sine x minus 1 over 3. Okay. Let's take another example. Oh, sorry, by the way, forgot to introduce myself for whatever it's worth. My name is Susale Mohana. I've taught A-level maths for over 50 years, and I'm just recording these lessons to help students like you revise and prepare for your exams based on what you have learnt in school. This is not a complete course on its own. It's a revision course to go over what your teachers who have done sterling work in the class have taught you. Okay? Right. Let's look at the next question. Arc cot x. Let's make it 2x. Now, there is no standard formula for cot 2x and I don't want to overburden you with 10,000 formulae. So from this, can you say 2x equal to cot y? So 2 dx by dy equal to minus cosec squared y. But I want answer in terms of x. So it is minus of 1 plus cot squared y, which is minus of 1 plus 4x squared. So dx by dy is minus of 1 plus 4x squared over 2. So dy by dx is minus 2 over 1 plus 4x squared. I hope I am correct. Yeah. Minus cosine squared, 1 plus cot squared, 1 plus 4x squared, dx by dy is that. Yeah. Okay. Suppose I have I'm differentiating, not integrating. So I'm taking the next example. Y equal to x squared tan inverse x squared, and you're asked to differentiate. U and V, product rule. So U equal to x squared, so du by dx equals 2x. V equal to tan inverse x squared. Please, you're doing differentiation, not integration. So dv by dx equal to 1 over 1 plus x squared the whole squared. That takes care of the tan inverse. And when I differentiate x squared, I get 2x. So it is 2x over 1 plus x power 4. So dy by dx equal to u dv plus v du. U is x squared times 2x over 1 plus x power 4 plus v is tan inverse x squared times 2x. Don't matter, simplifying. So it's 2x cubed over 1 plus x power 4 plus 2x tan inverse x squared. So that you're familiarizing yourself with differentiation. That was just a what you call a preliminary revision. Now we are back to integration. Integrate the following functions. Please add these to the formula book. You remember I had given a handout where we had the list. So if you're doing OCR, if you're doing for the maths, please add these too. And if, more if than when, I record lessons for further maths, you will have so many more because of the hyperbolic functions. Okay. Integrate the following functions. I'm alright with time, yeah. Integral 1 over 9 plus x squared dx. Remember, first method of integration. Can I apply the formula directly? If so, figure out what it resembles. This resembles 1 over a squared plus x squared. In place of a squared, I have 9. So your a is 3. So write it in that format. 1 over 3 squared plus x squared dx. The answer is 1 over a arc tan x over a. So it's 1 over 3 tan inverse x over 3 plus c. Yeah? Good. Let's take another example. Integral dt over 3 plus 16 t squared. Fine. It resembles 1 over a squared plus x squared. But it's not exactly the same, so write it in that form. So it's integral 1 over root 3 whole squared plus 4t whole squared dt. Now when you compare, your a is root 3, your x is 4t. When you differentiate 40, you get 4, which is a constant. If it is a constant, then I can integrate directly. So it gives me 1 over a tan inverse x over a. That takes care of the integration. But when I differentiate 40, I get 4, which is a constant. In integration, divide by the constant. So times 1 over 4. So it's root 3 over 12 tan inverse 40 root 3 over 3 plus c. I'm being precise. You can't leave a root in the denominator. So I multiply the top by root 3, bottom by root 3. Root 3 times root 3 is 3. 3 times 4 is 12. Yeah? Okay. We go on to make life more interesting, as we will see. Example 4, is it? Is it 4? No, it's 3. Yeah, example 3. Alright. So it's integral 2 over square root 1 minus 4x squared dx. You can't use numerator exact derivative denominator because there's a root. So this resembles a squared minus x squared. So it's 2 integral 1 over square root 1 squared minus 2x the whole squared dx. Perfect. When this resembles that, in place of x, I have 2x. See, I'm just going over repeatedly when to apply the formula directly, because this is a very common bit of integration. Ultimately, even if you have a kilometer-long question, finally you come to applying the formula directly. And you should know when you can apply the formula directly and what you should do. That's why, like a parrot, I keep on repeating. There's like an old gramophone record. Ring, ring. Yeah? Please don't mind. So when you differentiate 2x, I get 2, which is a constant. So I can integrate directly. So 2 times arc sine x over a. You don't have to write the 1. But when I differentiate 2x, I get a 2. So over 2. So the answer is arc sine 2x. Plus c, of course. Alright. But then I have 2 more examples to make life more difficult. Example 4, integral 1 over square root 9 minus 2x plus x squared dx. This doesn't resemble any one of those. We don't start integration or differentiation unless we have finished algebra and trigonometry. But why? I can complete the squares. 9 minus 2x plus x squared. Should I make it 9 now? X squared. Oh, sorry. It is no. It is 9 plus 2x minus x squared. 1. So I will put a minus 1. So I'll put it as 8. Okay. Remember, completing squares. But don't use half the middle term, because the minus x squared is always a nuisance. So write it as a minus bx plus c the squared. So it is a minus b squared x squared minus 2bcx minus c squared. So minus b squared x squared is minus x squared. So b equals 1. Minus 2bcx is equal to 2x. b is 1. So c is minus 1. Then a minus c squared is 8. A minus 1 is 8. So a is 9. So this becomes 9 minus x minus 1 the square. So the integral will be 1 over square root 3 squared minus x minus 1 the square dx. Now you see, in other words, if you have a quadratic in the denominator with no derivative of it in the numerator, you can straight away complete the squares and then use the formula. So this resembles 1 over a squared minus x squared. Your a is 3, your x is x minus 1. Can I apply the formula? What's the rule? Differentiate the extra function you have noticed. X minus 1. What do you get when differentiate? 1. It's a constant, so I can apply the formula. So it is arc sine x minus 1 over 3. And when I differentiate x minus 1, I get 1. So I don't have to write it. Plus. So whenever you have a quadratic in the denominator with no apparent derivative in the numerator, you have to complete squares. They will not tell you complete the squares and do it. You are expected to do that. And this method, please remember, for the math students, when your teachers teach you integration of hyperbolic functions, you will have the same thing, 1 over 2y squared minus 8y plus 17. Integral 1 over 2y squared minus 8y plus 17 dy. If it is not a perfect square, take it out. So 2 times y squared minus 4y plus 17 over 2 equal to 2 times ay plus b whole squared plus c. Always look, if it is a minus y squared, it is c minus ay plus b whole squared. If it is a plus y squared, it is ay plus b whole squared plus c. The only difference is it is c minus or c plus depending upon y squared is negative or positive. So I can don't have to bother about the 2. In fact, I'll just write it here, 1 over 2 integral 1 over y squared minus 4y plus 17 over 2. Okay. So that's a squared y squared plus 2aby plus b squared plus c. Of course, you can use any method you want, but I find this convenient so that I don't have to bother about negative signs and numbers and half the middle term and all those things. Yeah. A squared is 1, so a is 1. 2ab is 4, so b is minus 2. And then b squared plus c equals 17 over 2. So is it correct? Yeah. B squared plus c. B squared is 4 plus c is 17 over 2. So c equal to 17 over 2 minus 4, which will be 9 over 2. So once I do that, the question now becomes, I know ABC, I've shown you how to do it. I think my memory is good. So it is half integral 1 over y minus 2 whole squared plus 9 over 2. Yeah? Okay. This resembles the standard formula a squared plus x squared. Please understand, I have written y first purposely because somehow when it's like this, the students will say x is 9 over 2, a is y minus over 2. No, you compare the variable with the variable, the constant with the constant, and a plus b is the same as b plus a. So don't bother. Be careful, that's all. So it's half integral 1 over. To avoid the confusion, can I write it as 3 root 2 over 2, 3 over root 2 the whole square plus y minus 2 the whole square dy. So your a is 3 over root 2, your x is y minus 2. When I differentiate y minus 2, I get 1, which is a constant, so I can apply the formula directly. So it becomes half times 1 over a tan inverse x over a. So this root 2 goes up. So it is root 2 over 6 tan inverse y minus 2 root 2 over 3 plus c. Good. So I have shown you how to apply the formula. In the next lesson, we're going to do more complicated questions, splitting the numerator and then substitutions and then definite integrals. I don't know, there's so many things. I'll see you in the next lesson. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.